Hi, my name is Tom and you are at level 13 out of 30 easy steps to understand everything about Einstein's special relativity. In this level we will talk about Doppler and its effect. Not so much because we are so interested in Doppler, but it's an exercise. It's an exercise to switch perspective. And switching perspectives is a key thing on Einstein's mountain. We need to do this a lot. In fact, special relativity is nothing less than just changing perspective. Are you ready to train your brain? Let's go. GP, hit it! Christian Doppler. I'm sure almost everyone has heard of the Doppler effect. It's when a car passes by and the pitch of the car changes when it comes to you and passes you by. It's like so the pitch is higher when the car is coming at you and it's lower when it's moving away. The famous Doppler effect. Here he is. He is very well known. But as you can see, we are ranking the stars in most levels. He is not ranked among the greatest scientists and mathematicians here. But still, we all know about Doppler. So, this is taken from online source here, the Doppler effect. We're not going to spend that much time on it, but you know, it's a nice introduction into something else, which has to deal with changing perspective. And changing perspective is the core of Einstein's special relativity. And we can do this with the Doppler effect and all kinds of other imaginary situations. So here we see the official paper in which he describes it. So in fact, Doppler was changing perspective. So we are going to exercise our brain. Here we see a large piece of water. Is it called a pond? I think it's a pond, right? Or a lake. And in the lake are two entities. On the left we see a little rectangle which is a boat. And the boat will start moving from left to right. On the right we see a very small rectangle which is a observer, a swimmer, and he will swim to the boat. And people on the boat will drop rocks in the water, and a rock thrown in the water will create a circular wave in the water. So let's see the animation. Here you see dropping a stone, dropping a stone, dropping a stone, and the boat and the swimmer are moving towards each other. So this is it. And you see the famous Doppler effect. For the swimmer, the wavelength of the water waves seems shorter than the wavelength behind the boat. And that's because stuff is moving, right? And this is something you really need to get down and fully understand how to change perspective. So let's first look at the water waves. When you drop the stone in the water, it will just create a circular wave in the water. The water doesn't care that there is a boat and a swimmer in the water. The water waves don't care about those. It just, whenever it hits the water, it will create a perfect circle around the point where the rock was dropped. It only cares about its medium. It's changing the level of the water up and down. And in this case, I mean, it's hard to tell if you start following the boat with your eyes or you look at the compressed waves, etc. But if you just look at a single circle, try to don't look at anything else. You see that the single circle just grows. It does not move. It only grows, you know, but its point of origin doesn't move. It stays where the rock was dropped. And the velocity of each wave, no matter where, all the waves have the same velocity relative to the water, relative to the medium through which the wave propagates. And that's something really important to remember. So let's do an exercise on switching perspectives. Maybe this is the most important slide of all slides up until now. We've spent, I think, well, over almost 6 hours before we got to this point, but this is really crucial. You have to get this down. So let me break it down to you one more time. So here we have a piece of the water, and we are only interested in a single direction. Why? Because Einstein restricted special relativity into a single direction, in this case the x-axis. There is our boat, and the boat is moving at 20 meters per second. Well, 20 meters per second relative to what? The shore, the what? In this case, relative to the water. So do I have this? Yeah. So this is another really important piece, because I will use it all the time, how to write down the velocity here. We have the v, and then we have two small things next to it. The first thing tells you the velocity of what? And the second thing tells you with respect to which perspective, which point of view, relative to what. So in this case, the boat travels 20 meters per second relative to the water. And if the water is moving, the boat does not move at 20 meters per second relative to the shore, for instance, because the water is moving and then the boat is moving relative to the water. So you have to add those velocities, That's the whole thing. So let's do this. We have an observer. He's swimming with a velocity of 10 meters per second to the boat into the negative x-axis. So we can say the velocity of the swimming observer with respect to the water into the positive x direction is minus 10 meters per second. We have to put the minus in there because every velocity is being expressed in the direction of the positive x-axis. So if you're swimming back, there's a minus sign. Then we have these water waves compressed. Well, they are not compressed, they seem compressed at the front and stretched on the back of the boat. At the front, let's say that the velocity of these front waves is 30 meters per second relative to the water. We do everything relative to the water. You might not, and this is not really intuitive, but the waves on the back of the boat also travel at 30 meters per second relative to the water. Think about this. The waves are circular, they keep circular, so the velocity of this front wave, or the wave, I should say, is the same everywhere on the wave, 30 meters per second relative to the water. So we say the velocity of the wave relative to the water is 30. At the front of the boat, they move in the positive x direction, so it's plus 30. The waves in the back, they move away against the x-axis, so there it's minus 30. We're not interested in the velocity of the waves in the up and down direction or, some diagonal direction. We are only interested in the x-axis. So what is the velocity of the water relative to the water? 0, right? Very important on Einstein's mountain. The velocity of something from the perspective of something will always be 0. Always. And in special relativity, velocities are also constant all the time. So you can never tell whether you are moving, yes or no. So, then you just say, I'm not moving. Everyone around me is moving, but I'm not moving. So the water says, I'm not moving. I see the observer moving, I see the waterways moving, I see the boat moving, but I'm not moving. And now comes the exercise. Let's introduce some rules. So here I say, the velocity of something A from the point of view of A is always 0, I just said. And now this is the exercise. You have to do this. You have to pause the clip and you have to try to fill in the blanks. So what is the velocity of the water relative to the boat? What is the velocity of the boat relative to the observer? What is the velocity of the wave relative to the wave, etc., etc. Really, really try to do this on your own. If you can do this, you can master Einstein's special relativity, because Einstein's special relativity is all about changing perspectives all the time. So I'm going to give the answers now. There's a second rule. I should have told you maybe before you paused the video, but maybe you figured it out yourselves, which is even better. If you say the velocity of something A from the point of view B, then the velocity of B from the point of A is just a minus sign. If you are moving towards me, your velocity is in my direction, maybe the negative x direction, but from the observer, I'm moving to the observer. So you can just, when you switch perspectives between two, you just put a minus sign in front of the velocity. This is also a nice rule, which is not maybe that intuitive. The velocity of something A with respect to B, you can first say, well, let me see how A is moving with respect to relative to C, and then what C is moving relative to B. So you can go from A to C and from C to B, which in the end is the same as going from A to B. You just take an intermediate step. This is something you can use in your exercise as well. So here are the answers. Let's first apply rule number 1. The wave velocity with respect to the wave is 0. The boat velocity relative to the boat is 0. The observer velocity relative to the observer is 0. So we did the full diagonal and we put in the zeros. Next, let's apply rule number 2 for the things we already know. We see in the purple column, we already know some stuff. So we knew that the front wave is 30 meters per second in the positive x direction relative to the water. So the velocity of the water relative to the front wave is minus 30, right? So we did 30 minus 30. It's like a matrix, right? So next we know that the velocity of the boat relative to the water is 20. So if we switch perspective, what would be the velocity of the water relative to the boat? Apply rule number 2. Just put a negative sign. There it is. And we can do the same for the last piece of information we have. The velocity of the observer relative to the water was minus 10. So if we switch it around, the velocity of the water relative to the observer will be plus 10. That was rule number 2. The others are a little bit more difficult. I'm just going to give you the answers and let you do the math yourself. So the boat moves 30 meters per second if you look from it from the observer point of view, and the other way around, minus 30. The front wave is coming at me as a swimmer, the observer. Well, it's coming at me at 30 meters per second and I'm moving towards it with 10, so in total 40 meters per second. And if I switch it around, the wave will say, no, you are coming at me at 40 meters per second, and because that's in the negative axis, you put a minus sign there. Last, the wave moves 10 meters relative to the boat, because the boat is at 20, so that's 10 and it's minus 10. So this is it. You have to master this slide and do it over and over. I'm going to leave you with the punchline. I want to thank you for watching this level, and I hope to see you at level number 40. GP, hit it!